Alright, today I'm going to show you the factor tree method to find the greatest common factor. Okay, this truly works best with only two numbers. So let's say we have two big numbers and we don't want to list all the factors and then find the biggest one. Say 120 and 192. A good method to use for this can be the factor tree method, which many of you are very familiar with. Some of my students will know this as the finding friends method because we're going to look at the common factors, all the common prime factors. We know that 120, well, it ends in a 0, so that means we can divide it by 10, and 10 times 12 makes 120. 6 times 2 makes 12. 5 times 2 makes 10. 6 factors into 2 and 3. So there we have all of our prime factors. These are our prime factors because 2 times 3 times 2 times 5 times 2 would equal 120. And they're all prime numbers. 192. Sometimes it's okay to use a calculator so you don't make a mistake. Alright, well, what can we divide 192 by? We know that's an even number, so we can do 192 divided by 2 to find out two factors of this. So we know that 2 times 96 makes 192. Well, 2 is prime. 96. I can do this one in my head. I can split it in half to find out what we multiply times 2 to get. Half of 90 is 45. Half of 6 is 3. So 45 plus 3 is 48. Alright, break down 48. Let's see, I know that 6 times 8 makes 48. Not prime yet, so 2 times 3 makes 6. And 2 times 4 makes 8. And 2 times 2 makes 4. So there we have it, our prime factorization of 192. If we were to write our number as the product of all these circled prime numbers. Now what we need to find is the greatest common factor. We're talking about the biggest number that we can divide both of these numbers by, the biggest factor of both of them. So we need to look for friends. The friends that they both have. Which numbers are friends with both of them? Well, let's see. They each have Mr. 2 as a friend. So we cross it out to remind ourselves that we've counted that one already, and we write it down once. Okay? This is friends with both of them. Let's look for another number. They both have a friend that is a 3. So we write that down. Who else do they have? Oh, look, there's another 2 here. They're both friends with another 2, and they also still have yet another 2 as a friend. Alright, another way you could write this, since we're multiplying 2 3 times, you could write this as 2 to the 3rd power times 3. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24, and that is the greatest common factor. They all have these prime numbers as factors. We multiply them together, and we find our greatest common factor. The next thing I'm going to do is show you how to do it with 3 numbers. So right here, I have 3 numbers factored out. 3 factor trees, 3 numbers. 63, 84, 126. 63, we have 3 times 3 times 7. 84 is the product of 2 times 2 times 3 times 7. And 126 is the product of 2 times 3 times 3 times 7. Forgot to circle my primes. Remember, circle the primes, but only the primes. The next thing you need to do is, since we have 3 numbers, we want to find the friends of all 3 numbers. So to find our GCF, we say, who is friends with all 3 of these guys? Well, let's see. 1, 2, we all have a friend that is a 3. And what else do we all have? Well, all 3 of these numbers also have a 7 as a factor. So our common friends in these 3 are 3 and 7. If you notice, all 3 numbers have a 3 and all 3 numbers have a 7. So the GCF of all 3 numbers is the product of these 2 primes, which is 21. And if you notice the way I broke down my factor trees, it just so happened that 21 is a factor for all of these. So remember, find the friends, but only write them down once.